Yes, class, and welcome back to CapLandMathOnline.com. And today I'll be presenting lesson number 2 that deals with scatter plots and analyzing data. So if you take a look at the lesson over here, what we want to do here is just to revisit some of the skills that we did in the last lesson in terms of plotting points on a Cartesian plane. The only difference with this one is that we're now going to apply it to word problems or other types of questions that we'll be dealing with for the remainder of this chapter here. So just to summarize what we're going to do for today's lesson here, the first thing we have to do here is that everything that we're doing here is going to be applicable to things that you'll be seeing if you decide to take, for example, grade 12 data management where you'll be using things like Excel, spreadsheets, and other types of software for you to draw graphs. And what we want to do here is to first define the two types of variables we'll be looking at in this chapter. And at first, it might sound confusing, but when we go through different examples, I'm hoping that you'll clarify the difference between what are called independent variables and dependent variables. So what an independent variable is basically when you're taking a scenario and you have two different scenarios, the independent variable is the variable that takes control or is in control of another one. So for example, and I use this example all the time, is that if you have temperature, for example, okay, temperature controls whether ice cream melts, okay, or freezes and stays as ice cream. So the temperature controls whether the ice cream stays in what form it's supposed to be in. Okay, so that's the independent variable. Now, the opposite of independent variable is what's called the dependent variable. And what the dependent variable is the variable that depends on the other one. Now, I know it sounds very confusing, but if you want to picture this one over here is the fact that if you go back to the temperature and ice cream example, okay, the state of the ice cream, that would be the dependent variable because whether it stays as ice cream or it goes into liquid form totally depends on the temperature. So that's why when we look at the examples in the next slide here, okay, you're going to see that we're going to look at every scenario and then look at two possibilities in terms of which variable is which in order to make things just a little bit easier. All right, and basically the purpose of a scatter plot is to determine relationships between two types of variables. So basically what we also want to do here with a scatter plot is to look at a trend or pattern in the data that's given to us here. So if you take a look at the diagram, as you can see, we have age and height, okay, where age is the independent variable, okay, and the independent variable, when we start graphing it, will go on the horizontal axis, which you knew from the last lesson as the x-axis. All right, so in this case over here, okay, since age is the independent variable, that then controls the height, which is the dependent variable. So what that means there is that height, as you can see, it goes up, okay, is the one that's being controlled by the age. So a good way to explain this in words is as age increases, height increases. All right, so that's just an explanation of the relationship between height and age. So just like we did in the last lesson, as I said before, each of these points, okay, are expressed as ordered pairs or on XY coordinates. So we're going to approach it the exact same way. Now, I just want to talk about the letters here on the example over here. Notice we have an A here and an H here. Again, these are only variables to identify what the variables are. And the reason why it's A over here is because, well, it starts with age, and it's H here, well, because it's height. Okay, so again, these are just letters, but ultimately this is the same thing as the x-axis, and this one here is the same thing as the y-axis. All right, and one of the other words that you're going to see here, and you're going to hear this a lot, especially if you decide to take senior data management courses, is this word outlier. And basically, I like to refer to the outlier as a loner point. And the reason for that is because if you take a look at this data over here, notice that every point is over here, and you have this one single point that happens to be away from the rest of it. Okay, so that's an example of an outlier. Now, the main thing that you need to understand about an outlier is the fact that an outlier is a point that does not follow the general pattern of the rest of the points here. So notice that we have an outlier up here because the rest of them is going in an upwards direction, and they're tightly close together here as well. I'm just going to do a quick sketch of another possible outlier. So for example, if I had a point down here, okay, that would also be an example of an outlier because again, all the points here are following a general upward pattern or upward trend, and this one happens to be down here. All right, so again, that's just another example of an outlier to just to clarify what an outlier is. All right, so first thing that we're going to do here is we're actually going to look at different scenarios that involving independent and dependent variables. Now, as you can see here for each question, what we want to do here is to read the question, and then from there, identify which one's the independent variable and which one's the dependent variable. Now, the good way to think about what an independent variable is, okay, it's the variable that's in control. Okay, so when we look at these scenarios, we're going to ask ourselves, does scenario A control scenario B, or does scenario B control scenario A? And the variable that's in control, okay, that's the one that's going to be the independent variable. All right, so let's go to the first example so you have a nice idea in terms of how that works. So it says here, does the outside temperature affect the number of soft drink sales during the spring and summer months? Okay, so the ones I've highlighted in both the pink and blue respectively, these two are our variables. Now what we want to do here is identify which one's the independent and which one's the dependent. So that's why I always like to look at these two scenarios. Okay, does the outside temperature control the number of soft drinks, or does the number of soft drinks control the outside temperature? Okay, so I know that sounds funny, but that's probably the best way to determine which one affects which. Okay, so again, does the outside temperature affect the number of soft drinks, or does the number of soft drinks affect the outside temperature? Okay, so again, you have to ask yourself, which one here is in control? Well, we should know by, again, just using a little bit of common sense, if it's hot outside, okay, guess what? The number of soft drinks are going to increase. So in this scenario, the outside temperature would be the independent variable, because the temperature, okay, controls how many drinks are sold. All right. Okay, on the opposite hand, again, this is where well, this kind of sounds funny. Does the number of soft drinks, or does the number of sale of soft drinks change the temperature? Well, last time I checked, it doesn't. So that's another way that you can look at it as well. All right, let's take a look at the second one. Okay, is there a relationship between the time of the day, okay, and the number of coffee sales? Okay, so again, does the time of the day control the number of coffee sales, or does the number of coffee sales control the time of the day? So if you go to different coffee shops around the city, okay, you'll probably notice that most of the coffee sales probably happen in the morning. Okay, so the fact that at a certain time of the day, okay, there's an increased number of coffee sales. In this example, the time of the day, okay, is going to be the independent variable, because the time of the day controls the number of coffee sales. All right, on the opposite end, well, if we increase the number of coffee sales, okay, does the time of the day change? Well, last time I checked, we can't go back in time. It's not back to the future. So, well, we know that doesn't work. All right. All right, and the last one for this one here is, does the student's math mark depend on how much homework she does? Well, again, it goes with the fact that the more time you put into your work in math class, okay, the better your mark will be. So, does the math mark control the amount of homework, or does the homework control the math mark? Okay, in this case over here, okay, notice that the order of how the question is presented doesn't necessarily mean that's what the independent and dependent variable is. So for example, in this one, okay, if you read the question again, you can see that the homework, okay, is what affects or what controls the math mark. So the homework in this case, this one here would be the independent variable, okay, and the dependent variable would be the math mark. All right, so if you go through these three examples I gave you here, and then you look at some of the examples in your review, okay, you will see that a lot of them are very similar, okay, and just approach it the exact same way. Okay, so when you go through independent and dependent variable, just ask yourself, which variable is in control. All right, so moving on, let's take a look at the next example. Now let's take a look at a real example where we actually have a word problem, and then from there, create a scatter plot, and then from there, analyze it. So this one question that we're going to look at is going to take care of all the things that we looked at in the last set of examples here. All right. So what we have here is that this table lists the number of hours of driving instruction received by students at a driving school and their driving test scores. Now what we have on the top row over here are all the numbers, which represent the number of instructional hours. So each of these numbers here represents the number of hours that that student was in driving school. Now the bottom row all represents the student's score on the driving test. All right. Now, when you see a chart like this, okay, often at times, okay, what you have to see here is that the instructional hours and the student score are laid out to hint in terms of which one here is the independent variable and which one's the dependent variable. So, and I always explain this when you're given a chart, okay, the top row, okay, is a nice little hint that this tends to be the independent variable. Okay, now, like I said, that's 99.9% of the time, but we're also going to approach this the same way that we did in the last example. So, in this case here, does the instructional hours control the student score, or does the student score control the instructional hours? So in this case over here, if you take a look at the number of hours, okay, the instructional hours should have an effect on the student score. So since the instructional hours control the student score, the instructional hours will be the independent variable, okay, and the dependent variable will be the student score. Okay, so that's just using this information over here. Now, when we create a scatter plot, going back to the very first slide here over here, it's very important to know which one's going to go on the horizontal axis, or the axis going from left to right, and which one's going on the axis going up and down. Now, the independent variable, which in this case here is the instruction hours, okay, independent variable always goes on the horizontal axis. So that's going to go down here. So that would represent the student score to be put on the vertical axis. All right. So what we're going to do next over here, I'm just going to go to a grid here with some numbers. Okay, no, I'm just going to point out one little tiny detail here. Notice all the numbers in the bottom are going up by 2, and all the ones going up and down over here are going up by 10. Now, when you're creating a scatter plot, okay, we're just going to estimate where the points are going to go based on the numbers that we see over here. Now, this is where you need to figure out which one here is the X and which one here is the Y, okay, based on what we did in yesterday's lesson. So if you take a look at the instructional hours, okay, the instructional hours, as you can see, is on the horizontal axis, or the X-axis. So that means these top numbers here all represent the X's, whereas these ones over here, the ones on the bottom, okay, all represent the Y coordinates. Now, how we plot these will be based on how this chart is set up, where in this case here, the X value here would be the 10, and the Y value would be the 78. So we're basically going by column when we're plotting these points. So for the first point here of 1078, okay, I'm going to go right 10, okay, and then 78 is approximately between 70 and 80, just below 80. So there's that red point there. All right, we have 85 and 15, okay, sorry, 15 and 85. So we're going to go right 15, okay, and then up 85. Okay, so I think you should see what's going to happen here. So all the numbers on the top tell us how many to go right, okay, and the number below it tells us how many to go up. So for 2196 over here, I'm going to go to 21, which is in between 20 and 22, and 96, okay, which is just right above there. All right, so you can see that those are the first 3 points. Okay, we have 6 and 75, so we go right 6, okay, up 75. Okay, we have right 18, okay, and up 84. Okay, and we have 20 and 45 over here. Now for 20, we're going to go right 20 and up 45. That looks very interesting. Okay, make a note of that. And last but not least, we have 12 and 82 here. So here's 12 and 82. All right. So now if you take a look at these points, we have all 7 points on the same grid here. All right. Now what we want to do here is now take a look at this data and just to draw conclusions from it based on this particular word problem. So it says here, are there any outliers, and how do you know they are outliers? Well, if you take a look at the set of data, you notice there is one point that happens to stick out, okay? And it's this one over here. Now remember, an outlier is a point that does not follow the pattern of the rest of the points. So if you take a look at these points, you notice that they're going generally in an upwards direction, and you notice that there's this one point that's far away from the rest of them. Okay, and that's probably the best explanation for it, because this particular point, okay, does not follow the general pattern of the rest of the points there. Okay, so remember, the outliers never follow the pattern, general pattern of the remaining points on a grid. Now, for part D, it says, what is the relationship between the variables? In this case here, you have to come up with a statement that identifies the relationship based on the trend of this data. Now, what's important when you're determining what the relationship is, the order and in terms of how you explain the variables. When you're establishing the relationship between two variables, you must always state what's happening with the independent variable first. So you notice with the independent variable, okay, what you have to see here is as the instructional hours are going up, something happens to the student's score. Okay, and in this case here, as instructional hours are going up, okay, you notice that the scores also go up. So what's important here is the fact that when you're looking at the relationship between the variables over here, and I'm just going to highlight it here in blue, okay, it's this statement over here. The more instructional hours, okay, the higher the student's score there. All right, so again, notice that in this sentence, I stated the independent variable first, okay, and the second part of the sentence is the dependent variable. So you always have to state this first before state the independent variable first and how it affects the second variable. All right, so again, that just explains this relationship for this particular problem. Now, if you got a question, for example, where the points are going downwards, okay, then you would have to explain that the exact same way. The only difference is the fact that the dependent variable, you would have to just to say that it would be decreasing. But again, always take a look at the general pattern of the point and then just base your statement on the general pattern there. All right. Okay, so that concludes this lesson on using scatter plots to analyze data, and I'll see you on the next lesson.